Warmly welcome all of you to this session. And, Dialog is a pioneer when it comes to introducing new technologies to Sri Lanka. And we are in the forefront when it comes to contribution to our nation. So this tiny webinar on 5G is just a tiny part of a massive program we call 5G Innovation Center. So probably you all are wondering what this 5G Innovation Center is all about. Just stay tuned. Towards the end of the segment, I'll give you a brief introduction to what this initiative is. And here we have Chatru Peris, the head of Products and Service Innovation, to share a few words with you all. Chatura, over to you.
Thank you, Dineshika. I hope I'm audible, right?
Yes, go ahead, Chatura.
Yeah, good afternoon, team. On behalf of Dialog, I'd like to warmly welcome for today's online webinar on 5G. So just to brief you about the series of webinars, this is part of webinars as well as tech talk sessions we are planning to conduct in parallel to Dialog 5G Innovation Center program, as Dineshika earlier mentioned. So if I give you a quick, very brief intro about what is 5G Innovation Center, it will act as an open innovation hub stitching academia with industry to bridge next generation cutting edge industrial, fourth industrial revolution technologies such as 5G, AI, machine learning, big data, IoT, blockchain to these emerging markets. And then that will fuel these novel technologies to ideate, innovate, and then develop emerging market use cases. So you may be able to get more insights about our 5G Innovation Center program during today's session. So be with us and you will be able to grab a lot of insights about 5G as well as what are the activities that we are going to co-create with this university and the other industry partners, such as now here we have Ericsson also join hands together with Dialog together in giving this kind of a technology workshop. So enjoy the session and ask if you have any clarifications or questions during the session. So make it more interactive. And I hope that you will enjoy the session. Thank you very much. Over to you, Dineshika.
Thanks, Chatura. Yes, as Chatura mentioned, joining us today, the Ericsson team to share their experience and knowledge on 5G with us. And I believe we have Vinod Samaravikrama, who's the managing director of Sri Lanka, Ericsson Sri Lanka. Vinod, are you with us today?
Hello, yeah, yes, right. I'm here. So thanks, Dineshika and Chatura, giving us this opportunity. And I personally super happy to be here in partnership with Dialog, who is our technology partner in Sri Lanka. So if you give, if I give you a brief, introduction to Ericsson, we have been in presence in Sri Lanka since 1950s, and we have been with Dialog from the day one, launching 1G, 2G, 3G, and now we are talking about 5G. And yeah, so I think, and I have to thank Dr. P.Hewagamage and Thomas from our end, who is here with us today to basically share their knowledge, what we have been doing across the world and what is really relevant for us, and how as a country we should embrace 5G technology and foster economic growth. I think that's that's very, very important for us, how we use the technology to the betterment of the country. So without further ado, Dineshika, I would like to hand it over to you. Maybe probably you can carry on with the agenda. Anyway, thank you very much, guys. I think please feel free to ask any questions, and we are happy to hear for you guys to even today as well as any day to answer any questions and support you guys. Thank you very much.
Thank you, Vinod. Let me share my screen. Hope it's visible.
Yeah, we can see.
All right. So I'll give you a quick introduction to the speakers we have today.
You are not on full screen. We can see the presenter's view.
Sorry?
We only can see the presenter's view, not the full screen
Okay.
view. Yeah, now okay.
Is it all right now?
Yes, yes.
Okay. So we have today, I'll just give a quick introduction to the speakers we have. We have P.Hewagamage, who's the Assistant Manager, Network Strategy and Architecture from Dialog. And then Dr. Tiao Zhang, who's heading the Network Evolution Department in Ericsson, South Asia. And then we have Thomas Vidirecto, who's the Customer Marketing Manager from Ericsson. And then I'll be doing a brief introduction onto the demos and what we did during the 5G launch. And moving on, this is our agenda. So to start off with the first segment, I'm inviting Vindhya to carry on the presentation.
Thank you, Dinishika. So I will mainly talk about the background of cellular technologies and how cellular technologies evolved over the last few years and what 5G is. And then Dr. Tiao Singh will probably go into deep details about the technical aspects of 5G technology. So in talking about looking at these evolution of the technologies, first, if you go to first generation of technology, it mainly considered analog voice communication, and only about 10 years later, the second generation was introduced, and at this generation, the digital communication was enabled, and then the services like SMS and some data services was enabled, and with the second generation with edge and with GPRS and edge technologies, and here the data rates were only very small, and the users could only experience about 50 kilobits per second, and theoretically it could reach around 500 kilobits per second. And also a decade later, mobile 3G was introduced, and here the data rates were very much larger than the second generation, and the use cases like, hello, hope you can hear me. So you can, so the use cases were like the more data services and mobile internet was enabled here. The data rates were around 380 or 90 kilobits per second for the moving users, and could reach around 2 megabits per second for non-moving users. So the smartphones was smallly introduced during this decade, and then the fourth generation of technology came along around in 2009, and there are more richer content in the data services were provided, like streaming video and video downloads, and with the very high data rates compared to the previous generations. And the user data rates are around like 10, can go up to around 10 or 20 Mbps for the moving users, while it's around 100 Mbps for the non-moving users. So theoretically, actually, it could reach around 400 Mbps, more than 300 Mbps with more theoretically with LTE advanced and carrier aggregation technologies. So in terms of the technological evolution, providing these different services and enabling more performance, the technologies have evolved from the multiple access technology from FDMA and TDMA combination, and then CDMA, and then OFDMA, and also in the switching technologies from circuit-based to packet-based. So in terms of technology, there have been many changes, and the network architecture has been also changed in each of the generations, and then the next generation that will come along is the fifth generation, and it is already deployed and in many of the countries. And what 5G will offer will be much more different than the previous technologies. in terms of the capabilities, it can provide different services rather than the previous technologies, because previous technologies mainly focused on the consumers, like communication between the humans. It was human centric, and but 5G technology will go beyond more, will go more, will go beyond that. It will consider like machine type communication, and so mainly this is categorized into three types of use cases, and these will be explained to you in the next session in more detail. The first one is the extreme mobile broadband, that requires very high data rates and very high traffic density. And then the ultra reliable low latency communication, that is like mission critical communications that require very low delay and very high availability. And then massive machine type communication, that is enabling the communication between device to device communication or machine type communication, and it will connect millions of devices into the network, and the network should support connectivity of such mass number of devices into the network and support power consumption for such devices. So as you might see, 5G will be very different than the previous technologies, and there will be a lot of technological changes also here. And talking about we have to talk about the mobile data demand growth over the few years. So Dinshika, if you can go to the next slide. So as you might know, the mobile data and the fixed wireless data demand has been growing exponentially over the last few years. And obviously, the existing technologies won't be able to support such a growth in demand. And this is why the new technologies should be evolved very quickly and enable these services that consumers are requesting. So to move on, providing these new technologies, there are standardization processes in each of the generations of technologies like 3G, 4G, and 5G. And similarly, in 5G also there is standardization ongoing, and that has happened now. So, talking about this process, there is this ITU, International Telecommunications Union, that will provide the vision for the next generation of technology, like the goals and how much it should support, how much data rates, how much connectivity. So it will provide these goals. And in previously also, for before the third generation was evolved, it has provided IMT 2000 vision, and then with the 4G technology, it provided IMT advanced, and then before the fifth generation evolved, it has provided IMT 2020 vision for 5G. So the technological evolution, the support will be based on these goals provided by ITU, and then the research community and the vendors or the mobile network providers, the leaders in these industries will research and do the prototypes and trials and contribute to the development of the standards. So the 3GPP, the third generation partnership project, is the main body that will uh, standardize these releases that are focused on each of the technologies releases. For example, it has provided release 99 in releasing third generation, and release 8 and in LTE, and likewise it will provide different releases with improved enhancements and functionalities in each of the technologies. And it has provided the release of fifth generation of technology in release 15, and that is going to evolve more in the next few releases. Release 16 and release 17 is yet to be released. So all the vendors, the manufacturers of the devices, the equipment for the radio networks and all the core networks will base their equipment manufacturing on these standards, and the mobile network operators will also follow the standards and given by these standardization documents. So about what will work, how that will work, all these will be considered in the standardization. So in standardization of 5G technology, uh, what this providing a new spectrum was one of the key focuses for the fifth generation, because as you might know, the existing frequency bands that are used for the legacy technologies 2G, 3G, 4G are very much crowded currently, and so the requirement of much higher bandwidth can be provided in the higher frequency ranges like 3.5 gigahertz and then the millimeter wave ranges. So there is a big focus on providing the 5G technology using this higher spectrum. And the 3.5 gigahertz range is the key frequency range that is focused in fifth generation technology. And about this, how these are used, Dr. Seng will explain further. And also on another note, how the wide bandwidths are provided in the new radio, in the 5G new radio. With the millimeter waves and the higher frequency ranges, it enables higher bandwidths like 100 megahertz, and in millimeter wave ranges like 400 megahertz per carrier. And as you might know, in 4G, only the maximum bandwidth could reach only about 20 megahertz. And even if you aggregate, it could support only 5 carrier aggregation and could reach around 100 megahertz. But with 5G, it will be very much easier to provide with one carrier, and it also supports more carrier aggregation, like up to 16 carriers. And actually, you can carry aggregate up to 6.4 gigahertz. That is very huge. And then and talking about these different frequency spectrums, so also there is a focus on using these different frequency spectrum ranges in harmony for 5G technology. So, so these different kinds of different ranges of frequency have different performances, like in coverage and in the capacity. So so you have to use these different frequencies uh, suitable to the different deployments, like uh, hotspot areas, you can use millimeter waves, and for rural areas and very high nationwide coverage, low band frequencies. So also these enable different kinds of use cases with the different bandwidths provided. And as you might know, up to the frequency range 1 below 6 gigahertz and up to around 3 gigahertz, they are already used for 4G and 3G, 2G technologies. And with 5G, this millimeter wave is only introduced in 5G, and around 3.5 to 4 gigahertz also introduced in 5G. And you have to use these in harmony. And Dr. Seng will explain further how these are used. And moving on, uh, this using of different technologies, there is a problem of the AR interface to support the different structures. How do you support these different frequencies at the AR interface? So that has been solved by the NR in AR interface development in the standards. So they are using this concept or FDM similar to the 4G technology, but they have enabled this flexible subcarrier spacing in the subcarrier level. So it will enable to handle the different frequency ranges in the same AI interface. And as you might know, this high subcarrier component spacing can can use. So in the frequency domain, as you might know, when the frequency is high, in the time domain, the duration will be low. So likewise, it could provide low latency in the AI interface. So you can support these different kinds of subcarrier spacing in the same AI interface, and it has provided some more functionalities like bandwidth parting also. So that is the difference in mainly in the AI interface, and there are some other differences like in the modulation and also. So in addition to these, Dinshika, can you move? There are many other technologies that will enable 5G. So as I talked about the new spectrum. So in addition to that, this massive MIMO concept and beamforming will be used immensely in 5G. Um, Massive MIMO concept has been also introduced in 4G technology also, but it will be much enabled with the high frequencies, and it will enable like many high number of components in antenna elements, and it can support the coverage and capacity requirements and mitigating the interference. So uh, that will be a key technology in 5G, and Dr. Singh will surely explain in more detail how this works. And the other technology is the 5G and LTE dual connectivity. So in evolving the technologies, this has enabled like a smooth migration to the 5G for the network operators and the device manufacturers. So basically, this is the users are connected to both 5G and LTE, and it will be used in the initial stages of 5G deployments. And basically, the architecture, there are several architecture options also, and then the network slicing and service-based architecture of the 5G core. So in the 5G core, it will be mostly service-based, and the virtualized components will be used also, and this network slicing component will enable these different kinds of use cases I have talked before, this massive machine type communication and URLLC and EMBB, all these will be isolated and provided very easily to the end users. And then another thing is the multi-access edge computing that will enable these URLLC use cases because they require very high compute and very low delay at the that could provide at the users. So with the MEC, it will place the compute power near to the consumers, and so the computing and efficiency will be very much high, and the delay will be very much low as you expect in the URLLC use cases. And another thing is this softwareization of the networks, that is using the software defined networks and network function virtualization, and this has enabled this network deployments, and it has made it flexible and cost efficient, and to adapt the new different types of services that 5G network will further develop. So 5G technology is a merge of all these key technologies in providing the services to the next generation. So Dr. Singh will talk in more details about some of these key technologies in the next session. So moving on, I hope Dr. Singh can take over now.
Thanks, Vindhya, for the overview. So we have the next segment is we'll go deep dive into whatever the key highlight technologies given by Vindhya. Dr. Sen, over to you.
Yep, good afternoon, everyone. Right. Yeah, I think from the previous session, you look at what the 5G technology is, but then in this section, I will explain how is this technology being used, right? If you look at the four boxes here, right? So if you have a 4G, what 5G actually trying to solve, right? services trying to introduce. The first one is enhanced mobile broadband. It gives you a faster speed on your smartphone. Then on top of it, there are some areas without the fiber or without the fixed line access. It's actually 5G. You have a more spectrum to give you a high enough speed to cover those areas with wireless rather than the wired line, right? Then as you heard from a previous session, is also the new technology that cannot be supported by 4G, which is a very low latency. We call it the critical mission type of communication, right? Then of course, together with 4G, support the massive type of communication, right? Maybe one more click. If we look at the enhanced mobile broadband as a start, right? Can we click one time? Yeah, there is some animation. Yeah. So if you look at the enhanced mobile broadband today, right? If you look at yourself, you use probably a few years back, you use 1 gig of data on your phone. Today, you probably use 5 to 10 gig, right? So then, of course, in the operators network like Dialog, there are some sites in the urban, the traffic is really high, and some of the area in the rural, the traffic will be a bit low. But then with their FTD spectrum, they can only serve that much of traffic, right? That's why in order to handle this sort of traffic, more and more spectrum actually needed, right? Even in 4G. If we do one more click, then if we look at it, we start to explore the TDD spectrum, right? TDD spectrum like 2.3 or even the 2.6 on the TDD, right? One more click, then of course we explore more technology by making the TDD spectrum or the spectrum a bigger pipe, right? So with that, you have more capacities, right? But then if you one more click, then you actually do until a limit. There are still a portion that traffic cannot be handled, right? This is where 5G come in. The new frequency come in to handle this sort of traffic growth in the very, very dense traffic area rather than putting up a new site, right? So managing the capacity, you really need the 5G technology having a larger chunk of spectrum to handle more traffic, right? So if we do a one more click, if we look at the challenge that done by the operators, right? The more traffic you have, the more spectrum you have, you deploy. Come to from the left to the right, from 4G to 4G expansion to massive MIMO to 5G technology. The capacity provided by the site can be a lot more. In return, by deploying all the frequency in a single site, your cost to deploy the site can be lower, and the data provided by this frequency will be higher. So in return, it will reduce the cost per gigabyte, right? So, for example, a few years back, you're probably paying the same price for 1 gig of data. Today, you pay almost the same price for 5 gig of data. This has to be evolved by having more frequency and technology, right? If you look at the last bar, the 5G and more capacity actually can be handled by 5G. Why is that so? Maybe if you do one more click, it's all come to the two element, right? Yep, it's all about the 5G frequency and the massive MIMO, right? If you do a one more click, what the massive MIMO actually do, right? It's from the today 2TX of antenna. The antenna looks like this today, and evolved into a 64T, 64R type of antenna. That means you have a lot of antenna element in a single panel that you see on the rooftop, right? But what this will actually do, if you do one more click, because the 5G frequency, for example, 3.5, you have a so much smaller coverage compared to your 4G frequency. Then so the coverage will be smaller. By having all this antenna together, the beam can be actually steered towards one direction. If I do one more click, then we call this as the beam form, right? So the 3.5 gigahertz actually can cover your whole entire area or the cell range of your existing frequency, which is the 2.1, right? But not only that, because you can actually steer the beams towards one direction. If you do one more click, we actually can able to steer the beam to different direction, right? If you do a different direction beam, then that means the interference across everywhere is quite clean. right? Then we can, it's like rather than shooting a big area, now you're doing a laser beam to shoot to every users. By having this, the massive MIMO will give 3 to 5 times more capacity compared to the traditional one, right? So massive MIMO really a technology that increase the capacity, but that there is still a limit, right? 3 to 5 times. If we look at the 5G frequency, you click one more time, right? The 4G frequency is typically a chunk of 20 megahertz. If we go up to the 5G, we are talking about 100 megahertz, and in come to the millimeter wave, we are only talking about a gigahertz of frequency, right? So it will be 5 to 10 times more frequency, and in each of the chunk of the frequency, using massive MIMO technology, give you 3 to 5 times more capacity. Now we are talking about 10 to 100 times more capacity of 5G compared to 4G, right? Why is that so? Because you are watching video a lot more compared to last time, and you're still paying the same thing. That's why the 5G technology come in to provide more data, right? If we move to the next slide, right? So 3GPP on the left, you will see is define many frequency type, right? From existing band of 850, 2.6 to 700, right? To a higher band like 3.5, right? So you see some naming here, maybe it's a bit small. So the middle chart, the most deployed 5G frequency. Okay, by the way, today there are 130 to 140 network live today with 5G, right? It is more than 100 network, right? So what frequency that this network actually launch? Mainly is using, if you look at the bar in the middle, is the N78, right? Which is the 3.5 gigahertz, right? Then the second one down the line will be the N257, which is the millimeter wave spectrum. It's quite a lot of country deploy it, right? Then of course on the third one, it will come down. It will be the N28, which is the 700 megahertz, right? It will come down further. It will look at the come down to the existing band, which is the 2.1 gigahertz, right? So 5G has been deployed in different frequency, starting from the mid band, which is the 3.5 gigahertz, a lot more capacity, but then you start to come down to existing band to have a wider coverage. On the right, you look at the devices today, right? So devices actually support different type of frequency, 3.5, 2.1, 1800, all the frequencies, you name it in the industry, support 5G today, right? If we move to the next slide, right? Like I mentioned, out of so many frequency, which is the number one frequency to deploy first, right? In order to handle a lot of data, definitely we call it the mid-band. Mid-band, we call it our 3.5 gigahertz or 2.6 or 2.3 gigahertz band, right? This sum of spectrum, rule number one, you must have big enough spectrum. We are talking about 50 to 100 megahertz spectrum, so that you deploy one radio with massive MIMO, handle 100 megahertz of spectrum. It gives you a lot of bandwidth, a lot of capacities, so that you install one system, you handle the traffic for many years, right? If we move to the next slide, right, this is where the Korea actually start to deploy, right? So Korea is first Korea. There are three operators there: SK Telecom, KT, and LGU Plus, right? So they already start deploying 5G 2 years ago. If you look at the coverage map of this Korea, they're the first deployed in the cities, then they start to spread across nationwide, right? They currently already cover nationwide more than 90% of their population. If you look at the speed, each of the operators actually having 100 megahertz of spectrum, right? By deploying 100 megahertz spectrum and the measurement by their regulatory department, the average speed actually is around 600 to 800 megabit per second in average, right? So if we deploy 5G in the existing band, the 3.5 band, 100 megahertz of spectrum, we were expecting a few hundred megabit per second speed. Yeah? This is the speed that we are expecting, right? You move to the next slide, right? This is a spectrum that gives a big speed, but then another element is come to the antenna technology, right? If you look at the middle one, right, you have the red color antenna with a 4 antenna element, right? So if the antenna arranged in such manner, right, the coverage will cover 120 degrees, right? 60 degrees on the left, 60 degrees on the right, right? Because of more antenna element on the vertical, then it actually steer the stream to be flattened to cover most of the subscriber on the ground, which is 15 degrees up and 15 degrees down. This is the most common 2G to 4G antenna being used, right? But however, when it comes to the beam forming, we want the beam to be more steered towards one direction and able to move around and shoot to anyone. But how is it possible with the antenna technology? If you move to the right, you look at the blue color antenna. Now the antenna actually expand on the vertical domain, right? If you have more antenna element on the vertical domain, the beam can be pressed down and focus on smaller area on the vertical manner. If you have more antenna, for example, on the left is a one panel of antenna, go to a 4 panel of antenna, or so-called four times antenna size. The beam actually can steer towards a more narrow on the horizontal domain, right? So by a certain algorithm and feedback, so we call it the blue color antenna is a massive MIMO antenna. It is able to shift the actually beam to the left and to the right, to the top and to the bottom, to serve where the exact location of the UE is, right? So we call it the beam forming, right? But however, how about the tall building? Tall building, it is now in a high-rise building, right? If we squeeze down the antenna element on the bottom, then now the antenna actually can cover a bigger area, right? So or on the larger vertical space, right? If you look at the right, now it covers 60 degrees on the left and right and 30 degrees on the top and the bottom, right? So how we arrange the antenna and how we actually interact with multiple antenna will actually determine how well the beam forming is, right? If I click to the next click, right? So yep. So if the users is all separated across, a horizontal area, then on the top part is actually quite okay, right? If the users is actually it's a similar users, but now you have your antenna actually like something on the bottom, the power is actually shooting up the sky and shooting on the ground is no use, right? So the choice of antenna is actually on the top is better if the users actually distributed on the ground, right? If we move to the next slide, right? Now I'm going to move a little bit faster, right? Move to the next slide here. So in a suburban and rural area where users actually on the ground, there is not so many tall building, right? Then the antenna on the left, you see, I just have a long antenna and having a multiple panel arranged in the horizontal way. It will able to cover a flat area, but steer the beams to the left and right to do this beam form. On the right hand side of the chart, if you have a high-rise building, then we have to choose the antenna element, each one the color in the red in the blue box, right? So it will be able to cover a larger and vertical angular by having interaction between the antenna unit. You are able to shift the direction of the antenna to the left, to the right, and also to the top and to the bottom. Right. So massive MIMO, it gives you a flexibility and a different configuration to cover a flat area or to cover a high-rise building. Right. We'll move to the next slide. So this is the antenna technology, right? When it comes to the 5G architecture itself, right? When we call it the real 5G, you must have a few elements. First, if you look at the diagram, you must have a 5G core. The core network need to upgrade to a new 5G core. In the middle, you have a 5G base station. You have a base station, pull up the antenna, and you must have a new sort of a handset. We call it the standalone handset, right? And you do another click. There's another architecture called a non-standalone architecture, right? Now, you can actually pair up with 4G. Whenever you have a 4G, the user actually still hook on to both the 4G and 5G. 4G will give you a coverage, 5G will give you a capacity, right? But then if you do one more click, right, if we don't leverage on the existing band, which is the 4G, 5G coverage will be quite small. And if we do one more click, then the users is always come up from the 5G coverage and fall back to the 4G. Why is that so? Because a handset has a limited power, right? If you hook on to the 3.5, is this that much you can cover, right? If we do one more click, that's why the whole industry now is deploying a 5G non-standalone architecture, where the 5G handset actually hook up to the 4G frequency on the uplink, where your power is actually limited, but you have a strong frequency on 4G, which is the 1800, 2.6, or 700 or 900. While the downlink, you have a lot of power from the base station. You can push more power to match the coverage of your 4G, right? So that's why the whole industry is moving towards the non-standalone architecture as a start to give a big coverage of 5G, even though you have a 3.5, but because of the uplink, you're hooked onto the 4G, you're able to serve the 5G in a large area without building more site, right? But then when the UE actually evolved, you do one more click, right? In order to have the 4G and 5G in the same for the 5G UE to hook up to both the 4G, for the 5G user to hook up on uplink and downlink both in 5G, then we need to have the mid band to shoot down on the downlink on the 5G and convert some of the frequency band on the existing 4G to become 5G, so that the UE actually hook onto the system on the existing band via the 5G, right? So a better way to move to a pure 5G standalone system is you have to have a multiple band on 5G in order to achieve this type of deployment, right? If we move to the next slide, right? That's why the first priority to have the mid band, which is the 3.5 to deploy. The second one is, of course, go down to the existing band, which is the FDD band, that the frequency that you use for 4G handset today, right? Because it gives you a large coverage, right? So if we do the next slide, right? Today deployment, if we look at on the first one is the network with AT&T, in the middle one is VodafoneZiggo, and the third one is Swisscom in Switzerland, right? So they have a deploy 5G in a mixed manner, right? It's a low band plus a millimeter wave for AT&T, the low band, which is FDD, plus the mid band for Swisscom, right? So in the city area that you really have a high capacity, they will deploy the massive MIMO, deploy the mid band in the city. When it's actually moved out from the city, where you don't see actually much traffic, they only deploy the 5G on the FDD band, right? Of course, the FDD band will have a lower frequency, lower speed. If we click to the next slide, this is exactly the same methodology or method, right? We will move to the next slide. That deployed by Vodafone Germany, right? So this is a Vodafone Germany CTO. Is holding the phone. Call it the Ericsson spectrum sharing, right? So if you look at the chart on the right, that position the 3 frequency and the type of use case. 3.5 coverage small, but the speed is more than 1 gig. But the coverage can be quite small. It only can cover maybe close to your window. In the middle is a 5G on 1800 band. It's a bit of lower frequency, but now because of bandwidth is bigger, they position it as a 500 megabit per second, and they actually cover further deep inside the building, right? Then of course come down to 5G low band, which is a 700 megahertz, which is a super low frequency, right? This frequency can go very far, up to a few kilometers, up to 10 kilometers, even further. So they're positioned as a wide coverage, deep indoor building. So all frequencies actually important for 5G. You use a mid band for capacity and speed. You use the 1800 and 700 for coverage and deep indoor penetration, right? So with that, we move to the next slide, right? If you look at how we actually deploy, Ericsson come up with this innovative way to share the existing spectrum that you use for 4G today to be flexibly shared between 4G and 5G through, we call it the Ericsson spectrum sharing, right? Ericsson sort of invented this, right? So that you introduce 5G in the 4G spectrum, without so much of penalty or impact, right? So it gives the mobile operators like Dialog to have a very cost-optimized solution. For example, the 4G radio you can share with 5G. The computing that will come in, we call it the baseband, right? To all the processing, it's shared between the 4G and 5G. And the handset now, there is more and more handset support the 4G and 5G sharing in the existing band. Even the new iPhone 12 that actually launched last year, October, it support the spectrum sharing between the 4G and 5G. Right? So as long as the operator they turn on 4G and 5G technology in the existing band or existing equipment, you can have a nationwide 5G coverage very soon. Right? Then another advantage that I mentioned just now, if we move to the next slide, they come to the carrier aggregation, right? Because 3.5 coverage or the mid-band coverage is quite small, right? So by deploying the 3.5 of the mid-band plus the FDD band, which is the low band, right? Some of the signaling can be transferred down to the FDD band, right? And now we don't have a limit on the mid-band, and mid-band, the radio can actually have a lot of power to shoot. It can actually shoot quite far, right? So the carrier aggregation technology, actually by aggregating the mid-band and the low band together, by having some of the signaling transfer to the higher coverage layer, it will actually open up a potential for your mid-band or the 3.5 a lot, right? So in our in our test cases, by having carrier aggregation between these two bands, the coverage for the mid-band can go up 30 to 60%, and capacity increased by 20%, more than 20%. So by aggregating both the band, it's actually opened up the opportunity or capability to unleash the potential of your mid-band. Yeah. So last but not least, we go to the next slide, which is the millimeter wave, right? After we deploy having the mid-band, a lot of capacity, and also wide coverage. Now, in some of the area is really high capacity, right? Then we are talking about now having the millimeter wave to give you even a higher speed, right? We are talking about 800 to 1 gigahertz of spectrum, right? So the recent announcement that or the test done by Telstra or with together with Ericsson, we have 800 megahertz of spectrum plus 40 megahertz of FDD spectrum. It gives the speed of 5 gigabit per second. Yeah, 5 gigabit per second with the handset. We are talking about commercial system, not a test system, right? A commercial system today, the maximum capability that the network, the fastest network today is with the millimeter wave 5 gigabit per second, which is provided by Ericsson, right? If we move to the next slide, right? What to do with this so high speed and so much of capacity? Now the handset is very limited. Verizon in US, they have a lot of spectrum on millimeter wave. They actually open up a business opportunity to do a fixed wireless access, right? So they offer to the subscriber, I offer you a typical speed of 300 megabit per second in your house. I sell you this fixed wireless access terminal, which you can bring back and self-install. This one is the unit that is window mounted. So subscriber can bring back to the house, stick the modem on the window, and there is some application to tell you where actually you should install your CPE or your equipment, right? Then it gives you the best speed and coverage, right? With that, they also bundle together with some YouTube channel and also Disney channel, right? With a certain price and a subsidy. The pickup is really good, right? So apart from supporting your handset, and fixed wireless access is actually another segment, right? If we move to the next slide, right? Since we are talking about millimeter wave, actually the coverage is quite small, right? If we do a bit of tweaking, some innovation around it by providing a line of sight, millimeter wave actually can go quite far. We've done some testing in Australia with a millimeter wave, like 400, in this case, 400 megahertz of spectrum. We do it with NPN Australia. The distance actually can cover up to 7.2 kilometers. And at the car, you will see the user equipment, right? The speed actually can go up to 1 gigabit per second, right? So it's as long as you have a good environment, you install the CP on the top of the building, you actually can go very high speed, 1 gigabit per second at 7.2 kilometer. Right? So apart from this, if we move to the next slide, right, we are talking about enhanced mobile broadband. Now, if we do one more click, now we are talking about some other thing, which use cases that the 4G can't do, but 5G can do, right? If we do one more click, it's in the 2 dimension. On the x-axis, it's all about bandwidth. 4G, typically we talk about average up to 100 megabit per second, right? And on the latency, in 4G, we're talking about 20 to 30 millisecond, right? But to simplify it, we will say it is a 10 millisecond, right? So anything which is lower than 10 millisecond and any bandwidth that actually require more than 100 megabit per second, a lot high bandwidth, this is a segment that cannot be delivered by 4G. Those use cases can be a real-time gaming, it can be a fixed wireless access, it can be a virtual reality and augmented reality, or even autonomous driving that require a really low latency in order to work, which cannot be done with 4G today. Right. Then also there are some technology that developed in 5G to guarantee these our services. Right. For example, fixed wireless access, some office need a certain speed. You need to guarantee certain speed and offer the SLA to this company in order to charge them, right? We call it the network slicing. I give you a slice of the network, guarantee your throughput with my 5G big chunk of frequency. I can monetize based on my network. If we move to the next slide, that's why the network slicing is so important, right? One of the key elements that introduced in 5G rather than 4G is network slicing. Right? Network slicing, how it works, right? If we look at the bottom, it consists of end-to-end resource guaranteed across the network, from the radio access network to the transport to the core network. Right? For example, I'm doing online gaming on the handset, right? While I'm also watching YouTube. So YouTube will occupy all the bandwidth, but my online gaming, I must guarantee certain movement and guarantee the speed and latency, right? So the network actually can provide, okay, if you're doing online gaming, I give you this slice so that your guaranteed throughput and latency end to end from the handset up to the transport, to the core, to the gaming server. So I will guarantee my gaming experience, right? Not only cover the mobile broadband, right? If you look at the logo, there are some actually on the industry, like a factory, you have some robot, right? If you share something together with the YouTube, someone actually do YouTube. Of course, the signaling and the robot in the factory must have a higher priority because it's a critical type of application, right? Then the network can actually give you a slice so that your resource from a robotic arm can be guaranteed across the whole network, while not interrupted or impacted by anyone actually using the YouTube video, right? So network slicing is very important. If we move to the next slide, then what 4G can do and 5G can do now is 3GPP start to guarantee or standardize something called time critical communication, right? Why is it so important? For example, I have a robotic arm, right? Robotic arm, in order to make sure this robotic arm always connected to my system, there's a so-called the heartbeat of the system, right? And this heartbeat of the system always connected to this robot to make sure that this robot is always responding. When I move my cursor or whatever, this robot always responding, right? And so the response to the robot must have a certain delay bound. It cannot be I send a packet after only many seconds, only the packet actually do a response, right? So when I send a packet to communicate to the robot has to be respond very fast. Then this is the critical thing that need to be guaranteed, right? So the critical IoT communication is to guarantee the latency, we call it the bounded latency. Some require 1 millisecond, some require 5 milliseconds, depends on the application. That's why we call it ultra reliable, low latency connection. right? So you are see apart from this latency, more important is reliability. So this packet I sent to the robot, it has to be respond in a reliable way so that the connection is very secure, right? Because it's critical communication, right? And only 5G can do this, 4G can do this, right? And in a standalone network, only can do this, and you can't do it so effectively in a non-standalone network. You know? So hopefully I give you some glimpse on how the 5G technology is and what is the critical technology that is needed for the industry to accelerate and enable new use cases apart from the smartphone. Right? Maybe moving next, I hand over back uh, to other speaker. Right? Thank you very much.
Dr. Sen. So now we just good to know what are the technical, basically what are the technical aspects of 5G. And next, we will move on to the 5G use cases deployed around the world and some specific use cases which we can do in Sri Lanka. So Thomas, over to you.
Thank you, Dinshika. Just want to check my audio is clear.
It is Thomas. Go ahead.
Okay, thank you again. So good afternoon, everyone. Thanks again for this opportunity. My name is Thomas Fiderecto, and now I'm going to continue Dr. Tiao Seng's presentation to bring you to take a look further at 5G use cases, as people are having really high expectations from 5G when it comes to what are the use cases this new technology will be able to bring. But before that, let's spend maybe 1 minute to see what has happened in the 5G global market in the first 2 years of deployment. So first, Dr. Tiao Sang previously mentioned we have more than 100 5G networks globally launched. Well, it's actually more than 160 networks globally already launched commercially today. And it's also supported strongly by the 5G devices ecosystem. We already see that there are more than 700 devices types already commercially available. And by this end of this year, 2021, we also forecast that 5G will cover already around 25% of global population. And in South Korea, as per Q1 this year, we already see that 5G carries half of the mobile data traffic in there. And if we go back to the 162 live 5G network, maybe it's also worth to mention that Ericsson is actually powering more than half of it. We have powered 86 networks and spread in 43 countries. And you also heard the importance of the Ericsson spectrum sharing from Dr. Tiao Seng's presentation earlier, which enable mobile operator to be able to deploy 5G coverage rapidly, utilizing existing 4G spectrum. So no surprise that it's being deployed more and more. Currently, we already see that more than 120,000 5G cells are actually live with Ericsson spectrum sharing functionality. So all this clearly an impressive numbers to show how fast is the take up of 5G. And this number are growing every day. So I picked this numbers, I think like a few weeks ago. I believe if it's today, it's already going up all the numbers. So going to next slide, um, we are moving to the use cases. I think you've seen this same four boxes for segments from Tiao Seng's presentation before. What will be the use case of 5G? So 5G is use case driven. However, there will not be one use case that build 5G. Instead, 5G will be built on multiple use cases benefiting from its capabilities, which includes, I think, We've heard it before, but again, I would mention it includes more bandwidth and more, I think even more importantly, low latency and longer battery life. 5G serves both consumers and multiple industries and open up new business models across industries. Fixed wireless access can provide connectivity for households and small medium enterprise at the unserved areas or wireless fiber efficiently, and massive machine type communication where connectivity for millions of devices is needed but with low data volume, requires low cost and long battery life devices. And of course, this is one that only will be enabled by 5G, critical machine type communication, where you need resilient connectivity with stringent requirements of throughput, latency, and also availability. But out of all of these four, um, Ericsson actually has identified that enhanced mobile broadband is the first use case of 5G, um, which becomes a real opportunity. With the continued growth in mobile traffic, there's a need for a more efficient technology for spectrum utilization and also higher performance for new application based on virtual and augmented reality predominantly right now. And if we go to next slide, the background to this is that 5G is different compared to previous Gs due to the tremendous capacity and bandwidth, low latency, and reliability. I think we all have heard about that, and that 5G together with other technologies like mobile edge cloud, mixed reality, and so on, will enable new and advanced use case in new places, and I think more importantly, bring mobility to all those use cases. This could be immersive entertainment based on AR and VR, different kind of gaming, for instance, cloud gaming, multiplayer gaming, or 3D shopping, including maybe in the future, we have a vision that it will include multiple senses where you can feel the product, smell it, etc. And there's been many questions, of course, around what will be the killer application of 5G. And to answer this, first, I would want to go back in time during the 4G era, the emerging of the 4G era 10 years ago, for example. Uh, Many also tried to identify the killer app of 4G, but that time no one could imagine that actually transportation, delivery, would be arranged through ride-hailing apps. Food, many other stuff will be ordered through mobile. Movies downloaded, played, streamed, everything from your phone in your palm. All those delivered today using 4G. So I think this is going to be the same with 5G. We think right now at this stage, we will not be able to define a killer app for 5G. The killer app will be clear once the infrastructure has been built out. Then entrepreneurs, innovators will come with new applications on top of that 5G platform. And that will create multiple value compared to the infrastructure itself. It will be opportunities for all of you, I mean, all of us. So what 5G is doing is actually it provide an innovation platform for everything, all these upcoming use cases. Um, Next slide. However, of course, consumer have many expectations, and it's very important for us to understand it, especially those use cases expectation that they are likely to pay for it. To be well, it's important for us to be more become more innovative. Um, Ericsson Consumer Lab have conducted a study, and it's just released in the recent months. The study is titled 5 Ways to a Better 5G. You can visit ericsson.com and download that report there. So we tested different use cases concepts aligned with consumer needs to assess which one are the one that consumer feels are worth paying for, while also assessing their current stage of commercialization. So this graph here show the stage of each of the individual use cases mapped against their relative success in persuading consumers to pay more for a plan that 5G plan that includes any of them. So the commercialization of use cases were benchmarked at 3 stages. First one on the left side, those who which are we call it business ready. So these are the use cases that are currently already being bundled in 5G plans by few or many service providers globally, or are already widely available commercially. Then the second one in the middle, um, technology showcase. So these are the use cases that currently relegated to just technology demonstration by service provider. And the third one on the right side is use cases that are still R&D. So these use cases still require significant research and development to solve technology complexity or see ecosystem readiness challenges. So from here, we can see that there are already quite a number of consumer use cases for 5G, which already available commercially. Those are, in the left side, the business ready. But there are even bigger potentials coming up because, typically the one in the middle, uh, it's very possible to move to the business ready pretty fast. I mean, it's very dynamic market. As soon as there is commercialization opportunities, consumer demands, it's quickly moving up to the business ready segment. One very important thing I'd like to highlight is what we see or what consumers saying is that when 5G is offered as just a plain better connectivity, higher speed, bigger quota maybe, what consumer are saying is they are willing to pay premium, but only a slightly more premium. We see it's around, I think, 10% in average. However, when the 5G is offered as bundle with services that is highly relevant for them, they are willing to pay 20 to 30% more for it. So I think this is show the really the importance of finding or offering a really relevant business ready consumer 5G use cases. And going to next slide. This slide shows some real examples of 5G consumer use cases, which are offered by the South Korean operators. This includes virtual reality services, mainly for entertainment, with bundled offerings with the VR devices, the goggles. And we also see augmented reality applications for education, entertainment. Then they also offered enhanced video services, which is in this case, it's a 360 degrees video streaming with a 360-degree camera in the form of a neckband. So the person can wear it around the neck. It's a new, very innovative concept. Also, of course, don't forget one of the biggest industry globally, gaming. The mobile cloud gaming services is on the rise with the 5G connectivity now becomes available. So looking at all of these use cases, what could they have in common? Some of you might ask, well, those use cases are not completely new. Some has been around recently, started to be used with existing internet connection today. Yes, but I can say that now with 5G, all those use cases are be able to be deployed in the big scale, because 5G technology is enhancing the experience, providing them the required performance for the great experience. Higher speed, higher capacity means more people, more users can use these services. Um, Real-time experience due to the low latency, and I think most importantly as well, don't forget the wireless mobility. Some of these use cases are now can be done with a wired um, technology with fixed broadband, but with 5G, all of this able to be done wirelessly with mobility. So, okay, we go to the next slide, which we are now moving to the industry B2B enterprise segment. As of today, the opportunities for businesses to understand how to use 5G to improve the business has been mainly in diverse use cases in multiple different industries and in different domains. So Ericsson brings a holistic view on how 5G can add value by looking across all business process inside of a company and show how 5G is relevant for enterprise across various industries. There are a few business characteristics which will get benefit from 5G. Those are use cases with characteristic of remote control, doing remote control, and then needing flexibility. Those are need a very optimal performance, um, being predictive, doing real-time control, automated, doing automation, requires higher security, and also, of course, requiring a new business model. So these are the common characteristic across various industries, and in our study, it is across from agriculture, automotive, energy utilities, financial services, healthcare, up to all the way to manufacturing and retail. All these industries on the right side of the slide. And in this front, in the B2B, still go in the previous slide. 5G operators can have three options of roles they can play: as a simple connectivity and infrastructure provider, or can be expanded further as service enabler who provide a service platform, or up to as service creator who provides the applications and services directly. And our study with Arthur D. Little also forecast that globally in the world, the 5G enterprise revenue potentials for operators is up to 700 billion US dollar in 2030. And okay, we go to the next slide. How about the opportunity in Sri Lanka? Our further study also estimates that in 2030, there will be up to 1.3 billion US dollar of 5G enabled revenue in Sri Lanka. And out of this 1.3 billion US dollar, approximately half of it will be addressable for mobile operators. So it will be around 0.61 billion US dollar. This 0.61 billion USD also means it is approximately additional 34% of revenue growth potential to the current service revenue of what the operators are getting from the connectivity from the mobile broadband services today. So it's really a big potential of growth there. Very important uh, thing for business, for future growth. And but that then the next question is, okay, where are these business potentials exist, in which industries? And we see that the top 3 industries in Sri Lanka, based on our study, would be first manufacturing, mainly textile manufacturing. We see there are many global companies present in Sri Lanka. We also see energy and utilities, and also healthcare. But in addition to that, interestingly, I'd like to also highlight 2 important industries in Sri Lanka. The first one is port. It has a larger percentage share compared to global average. So in global average, port industry contributes to 0.5%, 0.5% share, while in Sri Lanka it reached I think around 6%. So we see there's a big push from the government to make Sri Lanka a logistic hub. So connected port use cases will be quite relevant for 5G in Sri Lanka. And then the second one is agriculture, also showing a larger percentage share compared to global average. We see 30% of population in Sri Lanka engage in agricultural activities. Next slide, just to summarize. First, 5G provides an innovation platform for many innovative use cases to be invented and to come to the market. And then the second point is we see that consumer market play a key role in 5G monetization. There are also many questions around, is 5G is more relevant for B2C, the consumer market, or a B2B in the enterprise market? Well, we believe, again, the first opportunities lies in consumer segment in enhanced mobile broadband. It's a very important segment because today 70% of operators' revenue coming from consumer segment. But of course, enterprise segment will be important as well. It offers a big growth opportunities, but the 5G success in the consumer segment will determine the success in the enterprise segment. And in this consumer segment, we also see AR, VR, enhanced video, gaming, sport experience, and fixed wireless access are among the first consumer emerging use cases. And of course, more to come. With this, I end my presentation. Thank you again, and I will hand over back to Dinushika. Over to you.
Thomas. We have come to the snapshot of Dialog 5G section. So in this, Vindhya will take you through and share with you our experience, Dialog's experience in 5G. Vindhya?
Thank you, Deshika. So, as you might know,
Vindhya,
hello?
your voice is very low.
Can you hear? Can you hear now? Hello?
Yeah, better now. Go ahead.
So, as Dialog, we have always leaded the industry with new technology in every time from the previous generation also. So, we have done extensive testing of these new technologies, including 5G, and in 2017, we first trialed 5G in Sri Lanka. So, and now we have launched the trial network, and that is for the first time in South Asia. So we have already provided the coverage in specific city areas in Colombo and suburbs. And considering the network aspects, we have used 3.5 gigahertz as the frequency, and the bandwidth is 100 megahertz. The radio technology in the equipment, we have used massive MIMO technology, and the network architecture is actually in non-standalone mode, and basically we are using the 4G EPC currently, as Dr. Seng explained before about the architecture, I think you might understand that. So currently we have experienced our peak user throughput around 1.6 gigabits per second, that is with a single user MIMO, and latency is always less than 10 milliseconds end to end. And normally the average user throughput is around 500 Mbps, and if you talk about the cell throughput, it reached around 1.5 gigabits per second, that is with single user MIMO, and it reached around 3 gigabits per second with multi-user MIMO. So we are still doing so many trials and testing new features with 5G, and so that is what I can currently say at the moment about the network. So Dinshika, I think you can explain about the Innovation Center and the use cases.
Sure, Vinda. Thank you. So guys, here I will showcase you a couple of demos we did during this 5G launch. So I believe now you can understand the gamut of 5G. Basically, like it's not just limited to high speed. It has the other capabilities like the ultra reliability and low latency and this massive machine type communications and features like that. So something I need to highlight is that when we were actually planning all these, demo use cases for 5G launch, we wanted to make sure we touch base all these aspects so that, we can make our general public aware that these capabilities are there with 5G. So without further delay, let me play the video so you can get understanding what sort of demos use cases we did. And the other thing is like even though these are called 5G demonstrations, we use a lot of other technologies as well, like a lot of artificial intelligence, then robotics, and then image processing, all these CNN algorithms and things like that. And this is a collaboration between all these technologies. And let's have a look at the video.
South Asia's first live 5G showcase is now on at Dialog iconic Colombo.
Randy is there and he's doing his hand movements, gestures and everything. And everything is captured by that webcam over there as a video feed. Then we are sending this video feed to a remote cloud server through 5G internet. Then in that cloud server, we are processing everything and creating this virtual skeleton, and we are converting everything into mathematical data. Then again, through 5G internet, we are transmitting all of those data to that robot. So that robot can respond to Randy right here and his movements almost instantaneously through 5G. And those are the stuff that we can do with Dialog 5G. This is a holographic calling device. With the device, you can have a holographic video call with another person in another part of the country, maybe on the planet. And this device is scanning the other person in the other side with 3D and sending all the data through internet, and so that we can create this holographic projection. To do this kind of stuff, we should have internet with high bandwidth and very low latency. With Dialog 5G, you can do that kind of stuff. One of the biggest advantage in 5G internet is its lower latency. I have a controller in my hand, and this controller is controlling this robotic arm. But it's connected through a 5G network, an internet connection. Still, I can control this robotic arm almost instantaneously. we can use this technology for lots of industrial application like remote surgeries, remote drone operation, and sending probes to hazardous location. And all those things are responding to the controller regardless of its distance because of 5G internet and its lower latency. This is a 360-degree video calling. My phone has this 360-degree camera. It has 2 cameras, and it's creating this 360 experience. And I can start a video call here, and from the other party, I can show around without rotating the camera. To do this kind of a 360-degree virtual reality video calling, we need higher bandwidth and low latency. Dialog 5G internet can cater this kind of requirements. And with Dialog 5G, we can experience this kind of a virtual reality video calling every day. This camera can create 4K resolution, maybe up to 8K resolution image. So we can use this for many cases and sending all of those video streams to this computer using 5G with its bandwidth and low latency. Then this computer is stitching together all of those 6 videos and creating a virtual reality video experience. Then we can stream it to YouTube, Facebook, or any kind of compatible platform. Then the audience can experience what this camera is recording from anywhere from this planet using this kind of a virtual reality headset. That means some person can be in another place on this planet virtually using this kind of technology. With 5G, with its higher bandwidth and low latency, we can make this possible.
So guys, that was just a glimpse of what we did at this 5G launch, the demo cases. Believe this is just a teaser to inspire you guys and to, wake the innovator in you. So we are moving to our last segment, which is about this. I'll give you a brief about 5G Innovation Center program and Innovation Foundry at Dialog. So to start off with, let me play another video. This is just a teaser video. This is basically a platform to ideate, innovate, and inspire. This is a platform to do cool things. Our main objective is, as Ivan Chatur explained during the introduction, our main objective is to basically stitch academia with the industry. Like all of you might know, currently these two verticals, acts very silo these days, and there's no much of connection between them. So we want to create sort of a connected ecosystem which supports co-development through this 5G Innovation Center and Innovation Foundry programs. So at the same time, basically we'll be catering to the demands of the industries through the talent pool in the academia. And while doing this, we will use the same program to basically empower our local innovators, basically you guys, and to uplift your knowledge. We'll have series of tech talks, webinars like hackathons, mini challenges, inter-university competitions, and things like that. And then also we will be, we want to promote all these collaborative R&D centers on 4G and 5G, 5G and fourth industrial revolution as well during this whole 5G Innovation Center program. And as you can see, these are a couple of partners onboarded to our 5G Innovation Center program. Well, we basically have state and private sector universities in which UCSC and UOM is part of. And then we have a couple of industry giants, joining hands with us to this program so that we will get continuous demands or the potential use cases to work with in this ecosystem. And then we have technology partners like Ericsson, and then hardware, firmware, and software, other partners who will basically provide the technology, required technology into this ecosystem. And then we are dealing with a lot of global innovation partners as well. one major objective of having this global innovation partners are to basically whatever the products we innovate or commercialize during this 5G Innovation Center program, basically to take them to the international market, we are using this global innovation partners as a channel. And then as another segment, we are trying to support our startups as well during the program, so that, if there's a good concept or a fine prototype or a good idea, after an evaluation, we will, go for a venture capital funding scheme. We have a couple of funding partners also on board to the program who can support all these products and services innovation done by this 5G Innovation Center. So if you want further details, you can contact us on Dialog, ic@dialog.lk. And basically, like, this is the whole session as for today. So I'm we are open to answer any questions if you have. Priyan, have you got any questions in the chat?
Yes, couple of questions. There is this one question: is massive MIMO do antenna changes to their coverage direction according to TDMA manner or FDMA manner? In there, right. I suppose.
Dr. Zen, would you like to take that question?
Yep. So the massive MIMO is actually very, very flexible. FDD and FDD is sort of you have 100 megahertz. Let's say you have 100 megahertz of spectrum, and also the TDD is on time domain, right? So when they do the massive MIMO, the beam actually steers towards one direction. If it is one user, of course, one user, we call it the single user MIMO. Everything will be allocated to one user. So the priority will go on the time domain first, so that you quickly transmit everything. Use all the antenna element to transmit to one user, finish the transmission, then move to the next user, right? But then if there are too many users come in, we call it a multi-user MIMO. Right? When it comes to a multi-user MIMO, that means now the massive MIMO will transmit two simultaneous beam together. This is where both the TDD and FDD domain will be sort of split to two different users. Yeah. Hope I answered the questions.
Yeah. We have another question from Professor P.Hewagamage. Believe, Thomas, you have answered this, but just in case, the question is 5G enabled revenues per industry, education is missing. I think, could you please re-answer to the question, Thomas?
Yeah, so thank you for the questions. Yes, it's not there. Unfortunately, education was not part of the 10 industries examined in our study. So we don't have the figures. So typically the 10 industries we include are based on the typical top B2B verticals, which have revenue captured by ICT players related to digitalizations. I believe education for sure have that share. It's just I think it's not part of the top 10 industries. That's why it's not included.
All right. Thanks, Thomas. And there's another question: will a core upgrade in the Dialog network be needed if the network is moved to either 5G NSA or SA? Linda, would you like to?
Yeah. So talking about NSA and SA both, of course, we require to upgrade the core because basically, even though NSA is using the existing 4G evolved packet core, it should support these control plane and user plane separation that is required in non-standalone mode, because mainly you might know that signaling plane or the control plane is going through 4G and the user plane is through NR or 5G. So the network elements, of course, have to be upgraded, and basically we had to upgrade the MME and the other also connectivity with high-speed gateways in S gateways and P gateways. So yes, and in talking about SA networks, of course, there will be huge upgrades because this SA core network, 5G core network will be very much different, and it is a service-based architecture based like it is based on network function virtualization also. So of course, there will be upgrades.
All right. Thanks, Vinda. And there's another question. Will there be a separate bandwidth and standards for IoT applications in 5G spectrum?
Yes. So talking about IoT, so in 4G also this IoT use cases have been enabled with narrowband IoT. So in that also we had to provide a small amount of spectrum, and it was called narrowband because of this you required only narrowband. So with 5G, as I explained in my slides about that spectrum usage, so basically you can partition this spectrum, the same band, the same cell bandwidth into different kinds of different slot structures, like how amount of the duration of this time slot will be different, large and small, supporting to different latencies. And but you don't require actually a different, exactly a new spectrum. You can use the existing spectrum efficiently with bandwidth parts and with likewise technologies enabled in 5G. So
Thanks, Vinda. So, due to the interest of time, we will take about another three to five
yeah, okay.
questions. Yeah.
So,
The next one I see, does 5G have an our worldwide connectivity? Otherwise, will that act as a bottleneck?
actually, the worldwide connectivity is provided through these packet data network gateways, and similar to the 4G networks, this has been enabled. And as we are using 5G NSA mode, the same architecture is used connecting to the packet gateways and next the packet data network. And likewise, if you use the 5G core networks, there will be this the same entities will be defined in a new manner, like data networks, and likewise the gateways. And there is not a reason like it shouldn't have the connectivity, and it is so I think I have answered that. So Dimshika, what's the next question?
Um, well, it's regarding, I think, Thomas's presentation. How do we get 22% of the 5G revenue from utility sector? Is this from smart metering? If so, what is the value added that 5G brings to utility compared to NB-IoT?
Yes, thanks again for the questions. Yes, for sure, smart metering is one of the use cases, or the source of use cases. But in general, we see it's more mainly driven in power generations, oil and gas area. And there are a few things driving it. Um, the first one is, there's a need to have a more resilient network that can address these industries, because okay, security, availability is really critical in this area, right? So yeah, resilient bandwidth, mitigation of cyber threats, so a more secure network is also the one of the benefits. um, and then the growth in oil and gas power generation is really big, high growth. That's why we see there's quite a very high potential in this area. In terms of the use cases, again, smart meters, smart grids are already start to be deployed. But the main drivers for 5G adoptions is actually, things like real-time operations, real-time monitoring of energy resources distribution. I mean, utilizing digital twins technology, and again, enablement of a secure, a different quality of service that is not achievable by previous technology. I mean, Dr. Chiao Sang mentioned earlier about ability to do network slicing, because I believe, of course, the slice of the network to be provided to this segment. This is a really high availability requirement segment. Will not be able to be, the same quality of service that is given to the other mobile broadband segment. So again, resilience, security, different quality of service using network slicing, and also to deliver new kind of use cases like digital twins and real-time operation, real-time monitoring.
Right. Thanks, Thomas. The last question, guys. Why there are two implementation modes for 5G? Is it to reduce the 5G launch time? We have a NSA mode. And in 5G NSA mode, does the 5G NR calling LTE core network?
So yes, Dinushika. So as I mentioned, there are few releases in 3GPP standards also. So in the first release, actually this NSA mode has been the first one to release, and then 6 months later, this SA mode, standalone mode. So why they have released this non-standard mode is make it easier to migrate actually. So the launch time will be obviously reduced, because for standalone mode there are many more functions to be enabled, like network slicing also, and some network function virtualization, software defined networks. All those are going hand in hand with standalone mode 5G core network. So also in network operators view, it will be very much cost effective to provide the services and easier, and the costs are reduced. So that's why non-standalone mode is provided, and to enable like smooth handovers to coverage wise, also considering the coverage, 4G coverage and 5G coverage, that is also enabled with non-standalone mode. So he's asking the non-standalone mode 5G.
I think you have answered.
Yes, it's using the LTE core network EPC, and it actually required an upgrade, as I mentioned.
Thanks, Vindhya. Okay. So everyone, we have come to the very end of the session, and a big shout out goes to the speakers as well as the participants. And thank you very much, Professor, for arranging this Zoom link so that we could conduct this session. And Professor P.Hewagamage, do you need to address?
Nothing much, but I would like to thank the Dialog and all the presenters sharing their experience and showing the use cases. I hope that will motivate the staff as well as some students who joined to contribute for the R&D work in the 5G area in the coming months. Thank you very much to all of you.
Sure, Professor. And I think we have Professor Dilika also from University of Moratuwa. Professor Dilika, would you like to share some words?
Yes, Dinushika. So I would also like to thank you for arranging this. with you in the 5G Innovation Center. And I hope we can have a lot of good work going, and also, some collaboration with the other parties like University of Colombo, School of Computing, and so on. So thank you very much, and I hope you will have more sessions like this in future.
Yes, Professor Dialog, definitely we'll be having a lot of tech talks, as I said, webinars, the hackathons and hackathons and so on. So guys, that's a small feedback form. If you can fill, it's just a matter of clicking 4 times. It's just a multiple choice sort of questions. We would really appreciate if you can give some feedback on this one. Yeah, we can wrap up. Thank you very much for the participation, guys.
Thank you, everyone.
Thank you.
Thank you.
Right. Thank you. Thank you.